Okay, so we're back for our section 7.7 part 2. We're going to take a look at solving ratios. And it will help to look at the problem of the book. For the problems that aren't necessarily word problems, I'll try to give you some diagrams to see how these are formed and put together. But I'm not going to do that with every single question here. So let's just start taking a look at question 37. And I have two triangles here. So one thing it's going to tell you is that the triangles are similar. And when it tells you that the triangles are similar, what it means to say is that the triangles do not have the exact lengths, but that the lengths, the corresponding lengths, are going to be proportional to each other. And for the sake of simplicity here, the orientation of these are kept pretty much the same. So we have here, let's just say this is a larger triangle, this is a smaller triangle, this is the larger triangle, this is the smaller triangle. Okay, so we're going to put together a ratio. By setting two fractions equal. The top will be large, and then this is going to be small. So the larger side is 7, the smaller side is 4. So these are what we call the corresponding sides of the similar triangles. So because of the shape, like this angle and this angle are going to be congruent, therefore the sides opposite those congruent angles are going to be not congruent necessarily, but they'll be corresponding. So if this is 7 to 4, compare this to this, we can say then that as 7 corresponds to 4, the value of b is going to correspond to 6. So we put a ratio together in this way. And the way we solve ratios is by a process called cross multiplication. By the time you have seen this video, you will have gotten the lesson in class for exactly the principles of cross multiplication and why they work. But in case you miss it or didn't have a chance to go to class or didn't make sense of it, here's more opportunity to learn how this works. So what I do is I take the top number to the left and the bottom number to the right, and then I take the bottom number to the left and the top variable, in this case, to the right. And if I take 7 times 6, and I take 4 times b. These two values should be equivalent to each other. So if I take 7 times 6 is 42, it should be equal to 4 times whatever the value of b is. Knowing this now, I can go ahead, divide both sides by 4. That's going to be the value of b of 10. Let's see, 42 will be 10.5, or 10 and 1/2 will be the value of b in this case here. So let's go over just a couple more questions in this way. Just one more question with a triangle here, because I don't think these questions are terribly difficult, but may help some of you to kind of go over these. So let's take a look at a question like 47, and then we'll kind of just go over a couple word problems. So we have a line coming out of here, and then from this we have two triangles. This length is 7, this length is 5. This length is r, so we don't know it, and this is 9. So obviously in the center we have the smaller triangle. This side is going to correspond to this side will correspond to this side. So the way we set up the ratio, smaller to larger, you can go larger to smaller too, but you have to be consistent. If you go large to small, you have to go large to small. If you go small to large, you need to go small to large. So if I go small to large, small to large, 5 to 9 corresponds with 7 over r. I put the ratio together that way. I'm now going to go ahead and solve this by taking 9 times 7, setting it equal to 5 times r. That's going to give me 63. That'll give me 5r. Then if I divide both sides by 5, r is going to equal this case is going to be 12 and 3/5 or 12.6. I would accept it in any form, as long whether it was a decimal or an improper fraction or a mixed number, as long as it was correct. So let's go ahead and take a look at just maybe one or two word problems to wrap up section 7.7, and let's see how this is done. Question number 49. The problem reads as follows. Brett sent or received 384 text messages in 8 days. At this rate, how many text messages would he send or receive in 30 days? So here's the number of texts, not tests, that would kill you, texts in days. And we're going to form a proportion with this. So he sends 384 text messages in 8 days. My God, that's a lot of messages. At this rate, how many messages will he have sent? So how many messages will he have sent in 30? So we should be able to cross multiply this to find out what this is and get an answer. So that's going to mean that 384 times 30 is going to equal 8 times x. So if my quick calculations on this are correct here, this is going to be 1152 is equal to 8x. So now I'm going to go ahead and divide by 8. And they ask you to have to do this work out. Okay? And if I divide by 8, that's going to go in here to 1. So the 3 remainder, 35. 4 is the remainder, 4. So I'm going to check my work quickly, but I do believe the answer to that is 144. So I'm going to get 1152 divided by 8. Yep, and that works out to be 144. Whoops. Oh, you know what I forgot? I forgot to add here. This is going to be 11,520. So if you got 1152 and you're wondering where I got that from, I did it incorrect because I only multiplied by 3. So it should be 11,520, which means this is not going to be 144. It means it's going to be 1,440. So in other words, whoever his name is, that would be Brett, he sends out in the course of 30 days 1,440 text messages, which maybe even 5 or 6 years ago would have been unimaginable and a parent's worst nightmare. We will take a look at this work a little more further in class to explain where ratios come from and how they solve problems. Next lesson, 7.8. See you then.